In today's lesson, we will go through a GCSE / grade 10 molar gas volume calculation. But before we look at the examples, let's recap the formula. It's moles is equal to the volume of the gas divided by 24. Now the volume must always be in decimeter cubed, dm cubed. And just to say where the 24 comes from, so for this level of calculation, we make the assumption that at around 25 degrees C and 1 atmosphere pressure is about 101,000 pascals. The volume a gas occupies is approximately 24 decimeter cubed. So 1 mole of any gas will occupy 24 decimeter cubed. So that's where the number is coming from. So that means if you're given the volume in centimeter cubed, you must turn it into decimeter cubed so that you can use the formula. 1,000 centimeter cubed is 1 dm cubed. So you take the volume in centimeter cubed and you just divide by 1,000 to turn it into dm cubed. So with that said, let's get on to the examples. So in the first two, we are given the masses of argon and the mass of carbon dioxide, and we've got to work out the volume of each one. But before we can work out the volume of each gas, we need to work out the moles because we're given the mass in grams. So for this, we need the solids formula. Moles equals mass divided by the RFM. So the mass of argon is 15 divided by its RFM, or its atomic mass. It's the same thing, which on the periodic table is 40. Gives us 0.375 moles. So now that we have the moles of argon, we can use the formula. Moles equals V over 24. And we need to rearrange to make V the subject of the formula. So V equals moles times 24. And the moles is 0.375 times 24. Gives us a final answer, 9 decimeter cubed. Same again for carbon dioxide. Moles of carbon dioxide, so moles equals 0.22 divided by the RFM of carbon dioxide, which is 12 plus 2 oxygens is 16 plus another 16. So that gives us 0.22 divided by 44 is 0.005. And then now I can just do the same thing as I did above. Gives us a final answer of 0.12 decimeter cubed. Right, finally, find the number of moles of the following gases. Again, measured at room temperature and pressure. That statement there allows us to use the formula, moles equals V over 24. So you'll see in both of these cases, the carbon monoxide volume and the hydrogen volume are both given in decimeter cubed. So this is a lot simpler. So we've got moles equals V over 24. So it'd be 48 is the volume of carbon monoxide divided by 24 gives us 2 moles. So what does that tell us? It tells us if you had 48 decimeter cubed of carbon monoxide at 25 degrees C room temperature and 1 atmosphere pressure, it would be equivalent to 2 moles. And then finally, hydrogen. So 1.2 divided by 24 gives us 0.05 moles of hydrogen.